We continue our discussion of inverse functions in Chapter 6, Section 2. We did not finish talking about secant and cosecant inverses, so we're going to hit that here. Again, we're not going to have to graph those. But first, we're going to talk about finding exact values of expressions that use these inverse function concepts. Okay, we want the exact value of cosine of tangent inverse of 3/4. So this information inside our brackets, tangent inverse of 3/4, that is a tangent function value of some angle theta. So this gives me information about an angle, and we want to find cosine of that angle. Let me see if I can get our focus a little bit better. Oh, that was not better. There we go. Okay, we want to find information on the cosine of that angle. So we want to know is the cosine of angle theta, and this is what we know about theta. Now, tangent inverse of 3/4 means that tangent theta is 3/4, and because it's positive and because of our restrictions for our inverse function, that means that that my angle theta is in quadrant 1. So we're going to kind of sketch that angle down here. We're in quadrant 1 where we have that positive function value. And think about why this is true. Tangent is restricted to quadrants 4 and 1, and it's negative in quadrant 4 and it's positive in quadrant 1, so we know we're in quadrant 1. We also know that our tangent function is y over x. So if we know that tangent theta is 3/4, then that means our y component is 3 and our x component is 4, and we need to figure out r. Now we need to figure out r because what we're asked to find is the cosine of this angle theta, and cosine is x over r. We already know x is 4. But what is r? That's what we need to figure out. Well, we've got x squared plus y squared equals r squared, our Pythagorean theorem. We know that x is 4, y is 3, so we can figure out r. 4 squared plus 3 squared, 16 plus 9 is 25. So r is going to be the square root of 25, which is 5. And our radius is always positive. So cosine theta is a positive 4/5. Let's do another one of these using tangent and sine inverse this time. Now remember, this sine inverse, I'm giving a function value. What I get out is the angle. So what I'm ultimately looking for is the tangent of theta. Well, what quadrant am I in? Sine inverse is restricted to quadrants 1 and 4 and 1. It's negative in quadrant 4, so I know I'm in quadrant 4. Let's set up a sketch over here so that we're in quadrant 4. We're in quadrant 4. The other thing we know is that the sine function value of this angle theta that's in quadrant 4 is going to be negative 2/5, and sine is y over r. So that means my y is the negative value. That's going to be a negative 2, and r is a positive 5. What I'm looking for here is x, so that I can get tangent of this angle theta. So x squared plus y squared equals r squared becomes x squared plus a negative 2 squared equals 5 squared. So x squared is equal to 25 minus 4 is 21. When I take the square root of both sides, because I'm looking for x and I'm in quadrant 4, x is positive, so I have the positive square root 21 as my value for x. And this is my information about theta, and I'm asked to find the tangent value of theta. That's what I'm ultimately being asked for. Well, tangent is y over x. Y is a negative 2. When I rationalize that denominator, I get negative 2 square root 21 over 21. Awesome. Okay, let's look at the next page, and we're going to introduce our inverse secant, cosecant, and cotangent functions. So these three reciprocal functions are what we're looking at next. These definitions, we're not even going to look at the graphs. We're just going to define them. Now, before we get down into this piece, I want to introduce the concept of that Y dominant, X dominant idea that I talked about in the last section. If you'll remember, when we had a Y dominant function, and our Y dominant functions were sine and its reciprocal cosecant, and tangent we said was Y dominant, it was restricted from negative pi half to positive pi half, which were quadrants 4 where it's negative, quadrant 1 where it's positive. Now, I didn't put any kind of brackets around here because it depends on which function you're talking about, whether this is inclusive or not. X dominant functions are the other three. Cosine is X dominant because it's X over R, and then its reciprocal function, secant. And then cotangent is X over Y, so it's included here. They're restricted from 0 to pi because quadrants 1 and 2 include all the positive and negative values when I'm looking at that x-axis. Okay, that's a really kind of good synopsis for you. And then here you get down into some definitions for these reciprocal functions. Y equals secant inverse of x means x equals secant of y. Remember, that's my two different ways to define it and talk about it. Where the absolute value of x is greater than 1. And because secant is the reciprocal of cosine, we're restricting it from 0 to pi. Now, secant gets to include those values, but remember that since x is in the denominator, if x is 0, we have a problem. So a secant inverse is not defined at pi half. Pi half is inside here. It's not defined at pi half. All right. So this would actually look like 0 to pi half or pi half to pi. But this is just a little bit more compact way to write that. Okay. Cosecant. Cosecant is the reciprocal of sine. So it is going to be restricted from negative pi half to positive pi half. Except we need to leave out the place. Oh, I'm so sorry. I got distracted. I got ahead of myself. As long as x is absolute value is greater than or equal to 1, because we've taken that for sine and cosine, we're looking at the middle. We flip that to everything else for secant and cosecant, so it has to be beyond 1, positive or negative 1. And then our restriction is from negative pi half to positive pi half, except we have to leave out that place where cosecant is undefined because y is 0. Okay, cotangent. Cotangent is x dominant. So it is going to be restricted from 0 to pi. I don't have to leave anything out here. And x can be anything. It doesn't have to fit those restrictions of being beyond 1. Okay, so that's just the definitions for my reciprocal functions. Let's go ahead and use that. Find the exact value. This implies we know we've got a special angle on our unit circle. Cotangent inverse square root 3 over 3. Well, because I'm given an inverse function, that means this is the function value and I'm looking for the angle. So that means I'm looking for cotangent theta equals square root 3 over 3. I'm looking for the angle theta. Because this is positive and I'm interested in cotangent, we're in quadrant 1. That's my restriction on inverse cotangent. What is the angle in quadrant 1 that has a cotangent function value of square root 3 over 3? Well, you either need to memorize this or pull out your unit circle to see that that's going to be 60 degrees or pi third. Exploration number 2. Now we're going to see how we use our calculator to do this. You don't have buttons for these things, but just like you can find secant of using our cosine button and cosecant using our sine function button, we can find secant inverse, cosecant inverse, and cotangent inverse as well. Now, secant inverse of x, that range of that function, just like we defined up here, is y is between 0 and pi except for pi half, because that's where it's undefined. We're going to use that as it's the same as the cosine function. So we can use inverse secant, convert it, find the reciprocal to get to secant inverse. The range of cosecant inverse is from negative pi half to positive pi half, except at 0, because that's where it's undefined. To find cosecant inverse, we're going to use sine inverse. Now, this is poorly worded. We're going to change the wording on this one again. The range of cotangent inverse is from 0 to pi, which is the same as cosine function, but that's not what we're going to convert it to. So, to find the inverse cotangent function, you're first going to convert it to tangent inverse. But you have to remember, remember that if cotangent inverse is negative, tangent inverse will return a value in quadrant 4, because that's where tangent inverse is negative. Not quadrant 2, which is where cotangent inverse is negative. Okay, so let's look at this. Let's think about this. If I'm starting with cotangent inverse is restricted to quadrants 1 and 2, and it's negative over here. It's positive here, it's negative there. But I have to use my calculator, and I'm using tangent inverse to find the angle. Well, tangent inverse is restricted over here. It's positive in quadrant 1, negative in quadrant 4. Now, if I start with cotangent and have to use tangent, I'm fine, because they're both positive in quadrant 1. But if I start with cotangent inverse, I'm looking for an angle in quadrant 2. But I have to use tangent inverse, I'm going to get an angle in quadrant 4. I'm going to have to rotate it around. Now, the way I do that is I have to add either pi or 180 degrees, depending on what my angle measure is, to think about rotating it to quadrant 2. Any angle I get for a negative value of tangent function is going to be in quadrant 4. I just need to rotate it into quadrant 2 by adding pi. All right, you know what? We're going to do one of those absolutely first. So we're going to look at the next page. We're going to do C, because that's what we just discussed. So we are going to focus on it right now before we forget. Cotangent inverse of negative 2/3. This is my function value. I need the angle. Well, cotangent inverse is negative in quadrant 2, but I'm going to have to use tangent inverse to get the result, because this is not a special angle value. Cotangent and tangent are reciprocal functions. So in order to use my reciprocal function button, I need to take the reciprocal of the function value. This is my function value. So what I can actually use is tangent inverse of a negative 3/2. Took the reciprocal of the function value. Now this is going to give me an angle in quadrant 4. So I know to get the quadrant 2 angle, I will have to add pi to rotate it over to quadrant 2. So let's do that. Let's do tangent inverse. I'm in degrees. I need to be in radians. Let's do radians because we're going to be adding pi. Okay, I'm going to do tangent inverse, second function tangent, of negative 3 divided by 2. That's the reciprocal. I'm using the reciprocal function. I use the reciprocal of the function value. And what I get is a negative 0.98. Remember, we're just rounding to 2 decimal places. Negative 0.98. That's in quadrant 4. I need to get it to quadrant 2. The way I do that is to add pi. because when I add pi, I'm literally rotating it a half turn up from quadrant 4 to quadrant 2. If I start here and I just say add pi, I get a radian value of approximately 2.16 rounded to 2 decimal places. That is my correct result. Okay, now let's go back over here to number 1. Or A, sorry, A. Secant inverse of 5. Well, is that an allowed value for my secant function? It absolutely is. Let me play with my document camera. Oh, there we go. That's a little better. If that is an allowed value, because remember, sine and cosine are restricted between -1 and 1. Secant and cosecant flip that out, and now I'm looking at anything beyond 1. So that's going to work. I take the reciprocal. So I'm going to use the reciprocal function. So I take the reciprocal of the function value. I'm going to use the reciprocal function, so I take the reciprocal of the function value. The reciprocal of secant is cosine. So I'm going to use cosine inverse of the reciprocal of 5, which is 1/5. And yes, that's a legitimate value for cosine inverse, for my cosine function. When I do that, let's see, I'm going to clear that out and say inverse cosine of 1/5. And I get a radian value of 1.37, approximately 1.37 as my radian, my angle theta that gives this, has this secant function value. Okay, so let's look at B. Secant, the inverse is cosine again, so I would have cosine inverse of 1 over 0.08. Well, now let's think about this. Secant inverse, my secant function has to be beyond 1. This is not beyond 1. If I do that, if I do cosine inverse of 1 divided by 0.8, I get a domain error. That's because 1 divided by 0.8 is bigger than 1. That's not within my acceptable values for a cosine function value. This is not within my acceptable values for a secant function value, so we are undefined. It is outside the domain of our secant inverse. Domain of secant inverse is beyond 1, the absolute value of 1. Let's do one more example just so that you have it in your notes. Let's do a cosecant. Cosecant inverse of 3. That's okay. That's going to work because that fits our domain of cosecant inverse. If I use the inverse, the reciprocal function, of cosecant is sine. So I would find the sine inverse value of 1/3. And I get a radian measure of about 0.34 when you round that to 2 decimal places. Now, we are going to skip this exploration 3. So if that is still part of your guided notes, just leave that off and don't worry about that. I did want us to go ahead and do one practice problem from our last section where we are going to find an inverse function again, because this is kind of a challenge for students typically. So we are going to find the inverse function of f of x equals -5 sine x plus 2. Now, when we are finding inverses, we have to restrict. So we're going to restrict the domain of f of our function to from negative pi half, not x half, sorry, negative pi half to positive pi half, because we're doing sine function. What about this range? What's the range of my function? Well, think about this graph. I've dropped my center down to 2, and from 2, I'm going to go 5 units up and 5 units down. Well, if I go 5 units down from 2, that gets me down to -3. And if I go 5 units up from 2, that takes me up to 7. So the range of my original function is -3 to 7. That's my amplitude. That's my center. Okay, switch and solve. So y equals -5 sine x plus 2. Switch, I get x equals -5 sine y plus 2. Now I solve for y. I subtract 2. Divide out that coefficient. So I have x minus 2 over -5 equals sine of y, and I take the inverse function. Sine inverse. I rewrite it in inverse function notation. F inverse of x equals sine inverse of a negative x minus 2 over 5. And I'm done there. And I already found the domain and range of my original function, so I say, okay, that means the domain of this function, domain of the inverse, is going to be from -3 to 7. And the range of the inverse would be from -π½ to +π½ If I wanted to algebraically solve for this domain, I would say that I started from -1. I've got x minus 2 over -5 to +1. I'd multiply both sides by -5, and I get 5 greater than or equal to x minus 2 greater than or equal to -5. And then I add 2, and I get 7. X is less than or equal to 7. X is greater than or equal to -3. And that is what I predicted from the original problem, thinking about the graph.